The goal of this protocol is to create and 3D print structurally accurate biomolecular models using an affordable desktop 3D printer.
This method is used to design 3D printable models of biomolecules starting from structural data and fabricate them using low-cost 3D printers.
3D printing of physical models facilitates interaction and discussion of molecular structure and function. Interaction with the models provides an intuitive perception that greatly exceeds what is possible using a computer.
To begin, first fetch the PDB structure file of the molecule of interest by entering the PDB code in UCSF Chimera. Next, thicken the diameter of the ribbon so that it can be successfully printed. Use the Ribbon Style Editor menu under Tools and Depiction. Under the Scaling tab, change the height of every item to at least 0.7 according to the structure type. To obtain a sturdier model, display the hydrogen bonds. Then change the pseudobond style to stick and change the radius to 0.6. Now, export the displayed representation as a 3D file. Select STL as the file type and save the model. Further processing is still required before printing. Repair is needed due to object overlap, which is very common in complex models. To correct this, open Autodesk NetFab and import the STL file that was exported from Chimera. In NetFab, open the Extras menu and select Automatic Part.